This is a video about Lesson 21 from Module 1, working on conversions with ratios methods. First thing you need to do is you need to take these two sheets here and you need to glue them into your math notebooks. It doesn't matter which order you glue them into, just make sure that they get glued in to your math notebook so you can have them as a resource. This is going to be a table of the measurements that work for the different things that we might need to convert. You are not expected to memorize these. Some of them you might have memorized already, but some of them you may not. You will have access to this on your test, and I know my grandma used to keep conversions in her cabinet, so in life you can make a list of the conversions if you needed to. But the main objective of today is to learn how to utilize them in a strategy that we already know. So this is your list of conversions. This is going to be your go-to resource to see step by step how to do the process that we learned today. So we just glue this in and then it'll be there if you need it tonight or if you need to show your parents the method. And this one I would leave out on your desk, like leave your math notebook open so that you could utilize it if you needed to. So after you get those, pause the video while you glue those in, and then when you have them glued in, go ahead and come back so we can work on the classwork section. If you are back, it means that you have your items glued into your math notebooks and you are ready to roll. You are going to need 2 highlighters today. I don't care necessarily what colors you use. If you want it to look exactly like mine, you can use yellow and blue. So today we are going to work on using the methods that we know how to use with ratios, and we're going to use that method to convert measurements. So feet into inches, inches into feet, feet to yards, yards to feet, cups to quarts, etc. So the first one we're going to do is you need this classwork page, which is lesson 21, getting the job done. And so we're going to start here with just, first of all, looking at the ratios. Some of these you might have memorized and you can just pull out of your head. Some of them you may need to utilize your conversion sheet that's in your math notebook. So once you have these written down, go ahead and check back with me to see if you have the same things that I have written down. So if you are back with me, it means you already wrote your conversion or your ratios down, sorry. So you knew that in 12 inches, that is the same as 1 foot. So the ratio that goes along with that, if we're comparing inches to feet, is 12 to 1. Remember, ratios go in the order of their words. Make sure you're using the correct ratio form as well. The next one would be 1 foot is the same as 12 inches. So that ratio comparing feet to inches is 1 to 12. These are 2 very different ratios based on the order of the words that we are following. The next one is 3 feet is the same as 1 yard. The ratio of feet to yard is 3 to 1. And then 1 yard is the same as 3 feet. So the ratio of yards to feet is 1 to 3. So now that we know that, now we can utilize the fact that these are ratio conversions. We can now look to see how we could use our double V diagram, which to me is the easiest one to use and is pretty cut and dry. So we're going to use the color coding just as an option. As always, this is just one strategy. If you can do it without the color coding, great. If you like the color coding, great. But I want everybody to be exposed to it so they could use it as an option if they wanted to. So the first thing I'm going to do is I'm going to read. It says work with your partner, and I'm going to be your partner today, to find out how many feet are in 48 inches. So the first thing I'm going to do is just highlight that feet are going to be blue and inches are going to be my yellow. So wherever I deal with feet, I'm going to mark it as blue. Wherever I deal with inches, I'm going to use yellow. So when we set up this to do the conversion, you always want to start with the original ratio, which you get from your conversion table. So the first thing I need to do is I need to compare feet, which is going to be my first line here, and inches, which is going to be my second line here. It's really important to me that you use your labels up here so that you make sure that you're matching up. If this is feet over here, then you know you're dealing with feet over here. If this is inches here, then this is inches here. When you have feet up here, you know that you're looking for the blue. When you have inches up here, you know you're dealing with the yellow. So the original ratio from our conversion table, if we look at it, it says there is 1 foot in 12 inches. So that tells me that our original ratio is 1 to 12. Then this is the extra information that the problem gives us, 48 inches. So that's where I'm going to put it into the second ratio of the area that I'm trying to solve something with. So since it's inches, it's going to go in the yellow spot, which is going to be here, 48. Now it's time to problem solve. And I asked myself, how many groups of 12 inches did I have in order to get up to 48? Well, I know that I have 4 groups of 12, so times 4 groups of, to get 48 inches. Well, if I have 4 groups of 12, that means I also need 4 groups of feet. So 1 times 4 is 4. So therefore, my answer, how many feet are in 48 inches? This is my answer here, so I would write 4 feet. So hopefully you can see the connections between the double V diagram, using that original ratio, plugging in the extra information they give us. It's the same strategies we've been using it. We're just applying it to converting measurements now instead of some of the other items that we were working with. So let's do one more together, and then you'll have some work to do on your own. So this one says, how many grams are in 6 kilograms? Again, I just kind of color code them. I'm going to mark my kilograms as yellow. I'm going to mark any information about grams as blue. So it says, make a record of your work before using the calculator. We're not going to use the calculator today. We can use our heads. The rate would be 1,000 grams per kilogram. Remember, when you see per something, that means for one item. So I see 1,000 grams per kilogram. So, again, just kind of color coding here. This is going to be my yellow options. These are going to be anything that deal with grams. Here. And, oops, here. I'm going to do my labels. This is going to be my grams. This is going to be my kilograms, grams, kilograms. Then the original unit rate is 1,000 grams per kilogram. So that means the 1,000 goes here, blue to blue, per kilogram, per 1 kilogram, yellow, yellow. The other information they give me is right here, the 6 kilograms. So that's going to go over here in the yellow, 6 kilograms. Now it's time to problem solve. In general, they will give you 3 pieces of information, and then you have 1 left over that you can problem solve to figure out. So I asked myself, how many groups of 1 kilograms does it take to get to 6 kilograms? It would take 6 groups of kilograms. So how many groups of grams do I need then? 6 groups of grams. 6 times 1 is going to be 6. 3 zeros in my question, 3 zeros in my answer. So that tells me that it takes 6,000 grams to be the same as 6 kilograms. So my answer here is 6,000 grams. So now I would like for you to try to read this information here. Try color coding on your own using the 2 examples we did together and see if you can solve it. So push pause until you have solved that problem and come back to check if you're on the right track. If you are coming back, you have solved exercise 1 and you're checking in to see if you are correct. So I just set it up. I read this and I knew I'm comparing cups and quarts, so I just color coded the cups blue and the quarts yellow. I need to figure out how many cups are in 5 quarts. So the rate would be 4 cups per quart. So cups to quarts, in this case, 4 cups per quart. Whenever I see per quart, I know that means per 1 quart. Then I noticed in my information up here, they told me about cups. That's what I'm trying to solve, is this right here. And they say in 5 quarts. So I put the 5 in here. And now it's time to problem solve. How many groups of 1 quart are there in 5 quarts? There are 5 quarts. So how many groups of 4 cups do I need? 5 groups of 4 cups, which makes it 20 cups. So there are, my answer would be 20 cups in 5 quarts. So now let's try exercise 2. Try it on your own and see if you can come back and see if I have the same answer as you do. So again, we're dealing with cups and quarts, so I'm just going to set it up the same way I did before. I have quarts and quarts. Here's my lines. Here's my cups and cups and cups. Cups, quarts, cups, quarts. I know that there are 4 cups to 1 quart. That's my original ratio that I could get from my conversion chart or from right up here. In the conversion chart, it would be over here where it says cups. This would take some figuring out because it's 1 cup to 8 fluid ounces, 2 cups in a pint, and then a pint is 4 cups. 1 quart is 4 cups. I guess it wouldn't. It's right there. 1 quart equals 4 cups. We got it. So now if it tells me that I have 10 cups, that means I need to put that information on that line. So now I'm ready to problem solve. How many groups of 4 cups does it take to get to 10? Well, that's a little tricky because 4 times nothing, whole number equals 10. So I might have to do some problem solving here. So how could I get to 10 cups? Well, if I had 1 group of 4 cups, that's 4. If I have another group of 4 cups, that would be 8 cups. I need 10, which means I need 2 more cups. So as soon as I see that, I kind of see that I need 1 group of 4 cups, 2 groups of 4 cups, and then this is really half of a group of cups. So I see that I need 1, 1, 1. I need 2.5 groups of 4 cups. I know that a half is 0.5 as a decimal, and I prefer to deal with decimals than fractions. So I'm going to put 2.5 groups of 4 cups equals 10. So then I know that I need 2.5 groups of 1 quart. So that tells me that 1 times 2.5 is 2.5. So 10 cups, these 10 cups would be 1 quart, 2 quarts, and then half of another quart, which makes sense in my picture. Don't forget to utilize that skill of drawing pictures and visualizing things. If you get stuck and you're not quite sure what to do, that's a great strategy to use. So hopefully now you can see how we can connect ratios with converting measurements, and you can use those strategies that we've used before to now adjust and convert measurements. Going back to this page, this is just showing you that this is the double V way to do it, your original ratio, what you're trying to solve, and some questions to ask yourself. If you I think the double V is easiest. If you absolutely hate the double V, you could also use a ratio table because we can use those conversions and just go all the way up. You can also use it as a tape diagram if this is one of your preferred methods. So I just gave you the information here so that you had some options of way to solve. For me, the best way is the double V, but again, you do have options. So now, if there is still time left in your class, I'd like you to get out a sheet of notebook paper, and you can go to Prodigy Game, and it should be conversion problems that you have, and I want to see you doing the work, setting up the original ratio, and then using the double V to solve for the missing part that they're asking for. And feel free to use your conversion chart if they don't give you the conversions or the original ratio that you need.